Good evening. My name is Suren, son of Krishnan. Today I'm going to present about engineering mathematics 2. And our topic of the presentation is integration. Introduction of integration. Integration is a mathematical operation that involves finding the integral or antiderivative of a function. It is a reverse process of differentiation which involves finding the derivative of a function. The process of integration can be used to find the area under a curve, the volume of a solid, or the average value of a function over a given interval. The integral of a function can be calculated using different methods such as substitution, integration by parts, partial functions, and trigonometric substitution. The indefinite integral and antiderivative of a function can be represented using the symbol fx, where fx is a function and dx represent the infinitesimal change in the independent variable x. The definite integral of a function fx between two limits a and b can be represented as the shown in the previous slide, which gives the area under the curve of fx over the interval ab. The value of the definite integral can be found using the fundamental theorem of calculus, which states the definite integral of fx between two limits a and b is equal to the difference between the antiderivative of fx evaluated at b and the antiderivative of fx evaluated at a. Integration is a fundamental concept in mathematics, and it has numerous applications in fields such as physics, engineering, economics, and statistics. Techniques of integration. There are five techniques. Number one, integral of trigonometric function. Number two, integral of exponential function. Number three, integral of reciprocal function. Number four, integration by parts. And number five, integration of partial functions. We can see the common functions and integral in the table given.
Hi, my name is Steven Alexia. My matrix number is 01DAD22F1070. Today I'm going to explain about integration rules. These are five types about integration rules: power rule, exponential, constant multiples, absolute value, sum, and differences. Example of application of integration in real life: calculation of areas and volumes. Integration is used to find the area of irregular shapes and volumes of complicated objects. For example, in construction, finding the volume of a complex building. Design can be done by integration, the area function of each segment. Physics. Integration is used to calculate the work but done by a force over a distance or displacement, and also to calculate the total energy stored in a system. For example, when calculating the amount of work done by an electric field on a charged particle, integration is used to integrate the electric field over the path of the charge. Statistics. Integration is used in a probability theory to compute the probability density function of continuous random variables. For example, a normal distribution function is represented using an integral, and the area under the curve of this function gives the probability of a specific outcome. Engineering. In designing structures such as bridges or buildings, integration is used to analyze the stress and strain on materials. For example, integration is used to calculate the bending moment in a beam under different loads. Economics. Integration is used in a microeconomic theory to calculate the area under a demand and supply curve to obtain consumer and produce surplus. This helps determine the best possible price that balances the interests of both consumer and products.
Questions. Given the graph of a curve with equation y equals to x squared plus 2x minus 2 and straight line y equals to x plus 4, determine the coordinate. Okay, question A. Determine the coordinate of the intersection point A and B. B. The area bounded by a line y equals to x plus 4 and a curve y equals to x squared plus 2x minus 2. The solution for question A and question B is shown in the slide above me.
In mathematics, integration is the process of finding the integral of a function. It is used to find the area under a curve, the volume of a solid, or the work done by a force. The integral of a function is the sum of its values over a certain interval, and it is represented by the symbol. Thank you.